Section 8.9 is on perfect squares. A perfect square trinomial is a trinomial that has the following form: a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, because it can be factored as one of the following: either the quantity a plus b squared or the quantity a minus b squared. Now this should look familiar from a couple sections ago, when we talked about the square of a sum and the square of a difference and how they can be multiplied into the trinomials that we have up above. So what we're going to be basically doing, in the previous section we had the sum and the difference squared and we ended up with the trinomial. Now we're going to be taking the trinomial and factoring it to get the sum or difference squared. And actually, you could use the methods that we used in a couple sections ago of finding two numbers that multiply to this and add to that. But if you recognize the trinomial as being a perfect square trinomial, it cuts down on a lot of the work, and you can just pretty much jump right to the answer. So, to explain how we do this. To recognize if a trinomial is a perfect square, the first and the last terms have to be perfect squares. So your first term has to be something like x squared, and your last term has to be something like 81. Then the middle term has to be 2 times the square root of the first term times the square root of the last term. So in other words, if I have a squared plus 2ab plus b squared, a is a perfect square, a squared is a perfect square, b squared is a perfect square, and then my middle term, 2ab, is a 2 times the square root of a squared times the square root of b squared. Once I've identified my a and b, I put them into parentheses. If I have a plus here, I get a plus in the middle. If I have a minus here, I get a minus in the middle. Put it in parentheses and square it. So let's try a couple examples here. We need to factor 9x squared plus 24x plus 16. What I like to do first is verify that this is a perfect square trinomial. So is 9x squared a perfect square? Indeed it is, because it's 3x times 3x. Is 16 a perfect square? Indeed it is. It's because it's 4 times 4. Remember, your first term has to be a perfect square, your last term has to be a perfect square, and then is my middle term, this is where I have to check it, is it 2 times one of these times one of these. So 2 times 3 times 4 is 24, times x is 24x. Indeed it is. So this is a perfect square trinomial. Notice that I have a plus right here in front of my b. So my final answer is going to take the 3x and the 4, put it in parentheses with a plus, and square it. That's how you identify if the trinomial is a perfect square, and then how you factor it. And I think it's a whole lot easier than going through all of the steps of a couple sections ago, where we would find two numbers that multiply to 9 times 16, and then the same two numbers have to add up to 24, and then go through the whole grouping. If you recognize that it's a perfect square trinomial, just throw the numbers into the parentheses. Let's take a look at another example here. 25x squared minus 30 plus 9. So let's first find out, is it a perfect square trinomial? 25x squared can be factored into 5x times 5x. 9 can be factored into 3 times 3. Now my big question, is the term in the middle 2 times a times b? Is it 2 times one of these? I forgot to put my question mark. There we go. Times one of these. So 2 times 5 times 3 is 30. It is indeed. It is 30x. Okay? The other thing I need to be aware of is that I have a minus in front of my middle term here. So my final answer is going to take all the stuff that I circled, put it in parentheses, 5x minus 3, and square it. We can also use this to solve equations. So I need to solve 4x squared plus 36 equals a negative 81. But before I solve this, I need to put it into ax squared plus bx plus c equals 0 form. So that's going to be 4x squared plus 36x plus 81. So adding an 81 to both sides makes it equal 0. Now, looks to me like this is a perfect square trinomial, but let's check. 4x squared is 2x and 2x. 81 is 9 and 9. Is my middle term a 2, because there's always a 2 in the formula, times 2x times 9. 2 times 2 is 4 times 9 is 36 with the x, and indeed it is. So this is a perfect square trinomial. So this will factor into, oh, and I've got a plus right here. I want to circle that. A 2x plus 9 squared. And since this is an equation, it does equal 0. But remember what this means is 2x plus 9 times 2x plus 9. I don't have to do it twice. I just need to do it once. So 2x plus 9 equals 0. Subtracting 9 on both sides and dividing by 2, x equals negative 9 over 2. And this one's a little different from a lot of the other equations that quadratic equations that we've solved. This one has only one answer. X equals negative 9 over 2. Now, square root property is another way to solve a quadratic equation. So, just to remind you, if x squared is equal to n, if x squared equals some number, then x is equal to the positive or negative square root of n. Basically what we're doing is we're taking the square root of each side. Square root cancels out a squared, and when we do it on the right hand side, we need to add this plus or minus. So here's a pretty straightforward example right here. So I have the quantity x minus 7 squared equals 36. So to solve this, I'm going to, I think I'll stay with the black, I'm going to take the square root of both sides. X minus 7 squared, take the square root of that. Take the positive or negative square root of 36. So x minus 7 squared, taking the square root of that, the square root sign and the squared cancel each other out, so I'm left with x minus 7, and that equals plus or minus the square root of 36 is 6. Remember, once you've taken the square root of something, the square root sign goes away. Okay, so I have an equation here to solve. I need to get x all by itself, so I will add, actually, no, the way I like to do it is I like to write this as two equations. What this means is x minus 7 equals a positive 6, and x minus 7 equals a negative 6. And I kind of like to write it like that. Okay, so x minus 7 equals either a positive or a negative 6. Adding 7 to each side, x equals 13, and adding 7 to each side, x equals 1. So to solve an equation that has a quantity squared, you can take the square root of both sides. Here's an example, x plus 3, the quantity squared equals 2. I'm going to go ahead and take the square root of each side. And that equals plus or minus the square root of 2. On the left, the square root sign and the squared can cancel each other out and give me an x plus 3. But on the right-hand side, I can't take the square root of 2. It's approximately 1.414, but I want to keep this exact. So I'm going to leave that as plus or minus the square root of 2. But I'm not finished solving because my solution needs to be in the form x equals. So I will subtract a 3 from each side. On the left, that leaves me with x. But on the right here, I can't combine something that's under a square root with something that isn't. So I'm going to write my final answer as negative 3 plus or minus the square root of 2. And I know that looks a little funny, but get used to funny answers because we're going to see a lot of them coming up in the future. And actually, I want to do one more example here that I didn't have written down. So here we have 4x squared plus 4x plus 1 equals 15. Now, the difference with this, the previous two examples, is I don't have anything in parentheses squared. But I can actually get this because this is a perfect square trinomial. So 4x squared is 2x and 2x. 1 is 1 and 1. And my middle term is indeed 2 times the 2x times the 1. There's a plus in front. So I can rewrite this as the quantity 2x plus 1 squared, which equals 15. So in other words, if your problem isn't given to you written as a quantity squared, go ahead and factor it, because chances are it's going to be a perfect square trinomial. Now, taking the square root of both sides, and on the right, don't forget the plus or minus, square root of 15. So square rooting a square gives me just the stuff underneath. And I can't take the square root of 15. That's not a perfect square. So I'll subtract 1 on each side. It's going to give me 2x equals -1 plus or minus the square root of 15. Remember, you can't combine those. And dividing each side by 2, because remember, to solve an equation, I need to have the x all by itself. So x equals -1 plus or minus the square root of 15 all over 2. And again, you have a very funny looking answer, but get used to it. There's more funny looking answers to come. And indeed, this is two answers. It's -1 plus the square root of 15, all divided by 2, and -1 minus the square root of 15, all divided by 2. So in this lesson, we took a look at, let me go back to the top here, factoring perfect square trinomials. So this is basically going backwards from what we did a couple sections ago, where we're given a perfect square trinomial and we need to factor it into a plus b squared or a minus b squared. So if you memorized those formulas before, now you just need to kind of memorize them backwards. And use the square root property to solve equations that did have a perfect square on one side.